In this video, we are going to use the selection sort algorithm to sort this list of numbers in ascending order. The selection sort algorithm works by first taking the value in the first position of the list and comparing it to the values in each subsequent position of the list. If any of the values compared are equal to a value less than the value stored in the first position of the list, the two values are swapped. This process is repeated with the second position of the list, then the third, and so on. If the length of the list is represented by n, then this process would run a total of n minus 1 times. The reason it would run n minus 1 times instead of n times is because by the time we get to the last position, there would be no subsequent positions holding values to compare it to, and the value of the final position will also already be in its sorted position. Let's look at an animation of the selection sort algorithm being ran on this list of numbers to get a better understanding of how it works. As previously explained, let's take the number stored in the first position of the list, which is 3, and compare it to all numbers stored in the subsequent positions of the list, ultimately storing the smallest number in the first position of the list. So first, we will compare it to 2, and since 2 is less than 3, we will swap these numbers. Next, we will take the number in the first position of the list again, which has now become 2, and compare it to 0, and since 0 is less than 2, we will swap these numbers. Next, we will take the number stored in the first position of the list again, which has now become 0, and compare it to 4. And in this case, 4 is not less than 0, so we will not swap these numbers. Instead, we will move on to the next number in the list, which is 1. And once again, since 1 is not less than 0, we will not swap these numbers either. And this will continue until the first position in the list has been compared to all subsequent positions in the list. And after that, we will continue on to the number stored in the second position of the list, and compare it to the numbers stored in all subsequent positions of the list. So first we will compare 3 to 2, and since 2 is less than 3, we will swap these numbers. And once again, this will continue until the second position on the list has been compared to all subsequent positions in the list. This will continue until the list has been sorted. Now notice we get to the point in the list where the second to last number in the list is to be compared to the last number in the list. In this case, 8 is being compared to 4. And since 4 is less than 8, these numbers will be swapped. At this point, we have made 6 passes on this list, or n minus 1 passes on this list. And as we can see, the list is already completely sorted. There is no need to run another pass using the last position in the list, because there are no other subsequent positions to compare it to in addition to it being already sorted. The selection sort algorithm has a time complexity of big O of n squared in the worst and best case.